Welcome to a short introduction to studying A-level physics at the Hertfordshire Essex High School. I'll start by introducing the course itself, then introducing the staff, and then for you to think about why you should study physics at Herts in Essex. Then we'll move on to a taster session where you need some equipment because you can do it at home. You study the AQA exam board, and if you follow the link, you'll find the specification and other resources. The course consists of 8 core topics and then an optional topic. At Herts in Essex currently, we choose to do the astrophysics. The assessments at the end of the A-level are 3 papers. Paper 1 and 2 are content-based, and then paper 3 tests you on your practical skills and data analysis, plus a section testing you on the options part of the course. Here's a screenshot from the specification from the exam board. This shows the content required and then also any skills that you may come across in that particular topic. As part of the course, you're required to do 12 practicals. We do, of course, do many other practicals as well. However, these 12 practicals cover certain skills that you need to get better at during the course. You'll have the opportunity to address each of these skills at least 3 times. So by the end of the A-level course, hopefully you will have passed the CPAC. Here are those 12 practicals. And also it references the apparatus and the techniques that you might use. And again, you can find more information about this in the specification. Hello, my name is Mrs. Dedman. I'm subject leader for physics. I've been teaching physics here at Herts in Essex for about 17 years. I'm keen for us to share our love of physics with you, and I especially enjoy the fact that in physics, maths has real meaning. I'll have the pleasure later of guiding you through a lesson where you can do an experiment at home. We're very lucky to have a team of 4 physics specialist teachers. Over to them to introduce themselves.
Hi everybody, my name is Mary Compton. I have been working at Herts in Essex High School for 25 years. I love teaching physics and I love teaching at Herts in Essex High School. I am very, very passionate about equal opportunities in maths, physics and engineering, and I work to challenge the stereotypes that exist in these fields.
Hi, my name's Mr. Beardwell. I love physics because I think there's something really satisfying about being able to take a little bit of knowledge and a few measurements and use them to work out how the universe works.
Hi, I'm Miss Heron. I've been teaching physics at Herts in Essex for just over a year. One of the many reasons I love physics is because it helps us to answer some of the big questions, like why is the sky blue? Or why does the world go round?
So, why study physics? Did you enjoy physics at GCSE? Of course you did, otherwise you wouldn't be watching this video. So you enjoy it? You revel in the challenge of finding ways to solve problems. You're wondering how the world works. You like taking things apart and trying to fix them back together again. This might be practically, or it could even be theoretically. You have a logical mind. You like to work through things step by step. You like experiments to find things out, and you want to make those experiments better, make them more reliable and more accurate. And you enjoy maths. What attributes does a physicist have? Of course, We've got a very logical and numerate mind, very good at solving problems. You can communicate with others. Lots of computing for modelling is involved in physics. And you can work as part of a team and be flexible. And why physics at Herts and Essex? We're very lucky at Herts and Essex to have 4 dedicated specialist physics teachers. We have an experienced physics specialist technician who can provide us with support for the practical work that we undertake. Our labs have all the equipment that we need for demonstrations and, of course, the individual practicals. Last year, students attended a lecture by the author of Particle Physics Brick by Brick, Ben Still, who shows physics in particles using Lego. Past students have also participated in the British Physics Olympiad, and we also give students the opportunity to help out with Key Stage 3 lessons so you can share your own knowledge and expertise and also improve on how you explain things to others. But don't just take my word for it. Here are some quotes from past and present students, and also a couple of videos for the students to explain for themselves.
Hello, my name is Harriet. I took physics, maths and English literature for my A-levels and I hope to undertake a physics degree. For me, learning is about asking questions and to push past the boundaries of the classroom. I chose to study A-level physics because not only does it infuse me, I've always been curious about it and there are still so many mysteries to be solved. I decided to stay at Herts and Essex to continue my education because the school offered everything I needed and more to further my learning and development. One of my favourite parts of the course was particle physics, which led to me attending a particle physics masterclass at Lancaster University in May 2019. I believe to be successful in studying physics, you have to have the motivation to work hard to accomplish your dreams. You should not be afraid of being confronted with new ideas and being shown new ways of applying them. Thank you, and I hope you take A-level physics.
Hello everyone, my name is Mohammed.
And I'm David.
And we both take chemistry, biology and physics A-level. So what was it about physics that we actually enjoyed at Herts and Essex?
I enjoyed massively the led lessons. They wouldn't give the answers to you just on a plate. They would give it as a group discussion, get you to think about it properly.
I agree. One of the key things that I enjoyed was when the teachers would challenge our thought patterns and how we think about science in general. So we'd look at, okay, this is what we learned in GCSE, here's a theory, play with this, the experiment, and now as a group discuss why is this occurring, why is it when X interacts with Y this event occurs. And I think that really helped us on our problem solving skills, being able to think for ourselves, rather than learning definitions by heart but not actually understanding them.
Yeah.
Also, the teachers were they were good fun as well. Like, they were really knowledgeable in their fields, but genuinely approachable people. I mean, what would you say about them?
Some of their explanations were really good. Like, a lot of the time, I wouldn't grasp a concept at the time, and so their explanations helped me grasp it with not just giving me the facts, if that makes sense.
Physics is a tough A-level, especially out of the ones that we took. I'd say it's probably the toughest. So having that support there was really useful. So I definitely recommend Herts and Essex on that basis.
Hello, I'm Alex, I'm in Year 12 and I'm currently studying physics as well as chemistry, maths and further maths. I joined Herts and Essex Sixth Form at the start of the year from Leaventhorpe School in Sawbridgeworth. Now, why should you study physics? Well, for me, studying physics was an easy choice. I think the idea of being able to develop an understanding of how the world works sort of all around you is really fascinating to me, and that was probably my main reason for picking the subject. Now, what I really like is the course is really varied. You learn all sorts from nuclear physics and radiation, which is probably my favourite thing. I'm hoping to do that at uni eventually. But you also learn so much more with electronics, forces, pretty much everything you do at GCSE, and a whole load more interesting stuff on top. The lessons are always really interesting and really fun, especially the practicals. They're probably my favourites. Now, you might be wondering if I have any tips for people that are coming up into Year 12 and want to do Physics A-level, and I do. The one thing I'd say is become really confident with the GCSE stuff. Make sure you know that off by heart and know that really well, because I think some people that don't have that foundation might struggle a bit and see it as quite a big step up. But as long as you know all your GCSE stuff, it should be a really smooth transition and you'll be doing fine in your A-levels. So thanks a lot for watching, and hopefully I'll see you next year.
And after studying physics at Herts and Essex, you may ask, what on earth can I do? Well, of course the answer is anything. There are no limitations. Everybody thinks highly about A-level physics. Whether you want to continue your research in physics, or perhaps some engineering, or maybe even a course in law or journalism, a physics A-level from Herts and Essex will get you far. A physics taster lesson at Herts and Essex High School. And yes, you can do this one at home. Before you start, you need to make sure you've got the correct equipment for you to do this practical at home. We're going to investigate the relationship between the length and time period for a simple harmonic oscillator, for example, a pendulum. For you to be able to do this, you need some sort of household item that will swing to and fro, like a pendulum. You need to make sure you can easily adjust its length and that the bob on the end of the string is a big enough mass that it's more massive than the string itself. You also need for it to have low enough friction so it can swing freely for at least 10 oscillations before stopping. If it does more, that'll be great. Of course, we appreciate not everybody has science equipment at home, so here are some ideas for you to look for in your house. On the following slides, we also have some photographs of what some of the students decided to use while they were at home during lockdown. And don't forget to take your measurements. You'll also need a phone for a timer, or you could have a watch, and some sort of ruler or tape measure so you can measure the length of your pendulum. This student found a mass which had a hole in it that they hung from their gym frame at home. This student chose to use their Lego seagull, which was suspended from the ceiling. And here, a mobile phone charger is hanging from a curtain pole. And don't forget, experiments can be risky. So please undertake a risk assessment of you doing this at home. Ask yourself, is it actually safe? What could happen? How could you prevent the accident from happening? And what are you going to do if something does happen? Now, fortunately, we don't believe this experiment is very dangerous. Perhaps the only thing you need to watch out for is your object that you're swinging dropping on the floor, so mind your toes. So here's the starter activity. This is Bob. You should have your own Bob now. Give him a swing. What might affect Bob's motion? What problems can you already see with your swing? Pause the video now and jot down some of your ideas. What did you come up with? The mass of the bob? The angle you swing from? How high you pull it? The length of the string? And the problems? Does it come to rest quite quickly? Does it wobble as it swings? Does it swing too fast? You may need to adjust some of these now, or perhaps you may wish to discuss these at the end of your experiment. Many things in nature wobble and wiggle in a periodic fashion, and we say they vibrate. One such example is our simple pendulum. If we suspend a mass at the end of our piece of string, then we have our own simple pendulum, just like you have made at home. Here are some other examples where the motion is what we call periodic. That to and fro motion, or oscillatory motion, is called simple harmonic motion, and this is part of the second year course in Physics A level. You might recognise this character. It was Galileo who first did experiments with pendulums and investigated the time it took for the pendulum to swing backwards and forwards through small distances. This motion to and fro is called the time period. The time period is measured from its start position through the cycle and then back to when it reaches its start position again. It turns out that this equation describes the motion of our pendulum. And of course, Galileo would have done many experiments to prove this. Where T is the time period in seconds, L is the length of the pendulum in meters, and G is the acceleration due to gravity, which you will have come across at GCSE. Of course, it's constant on Earth. So, look back at what factors you thought might affect the motion of the bob. But what does this equation tell you? Pause the video while you have a think. Well, did you come up with this? It actually tells you the mass of the bob doesn't affect the time period. You don't believe me? Go ahead and try it after you've done this experiment today. The initial height you start at doesn't affect the time period. Okay, well, let's just make sure we only do this for small angles. The length of the bob and the acceleration due to gravity do have an effect on the time period. So, in our experiment, let's look at the variables. What are we going to change? What are we going to measure? And what are we going to keep the same? Why do you think this might happen? Can you turn this into a hypothesis? Pause the video while you have a think about those questions. So, we're going to choose this as our hypothesis. The longer the pendulum, the greater the time period. Here are some simple instructions of how to carry out your experiment. Pause the video to decide how you are going to record your results. Hopefully your table looks something like this. The length of the pendulum in meters, time for the 10 oscillations in seconds, then a calculation for the time for one period of oscillation. And then we have a final column, which we'll discuss later. Pause the video to make sure you have this written down. So why are we going to time 10 oscillations? One oscillation happens very quickly. This makes it hard to time as our reaction time becomes a factor. If we time 10 oscillations, it means we can find the average time taken for one oscillation. You will also need to decide how many different lengths you are going to choose. In other words, what range? In science experiments, we suggest taking 6 or 7. This means when you plot the graph, you have got enough points to decide whether there is a pattern or not. So, once you've got your results, what should you plot? In science, we look for a relationship between variables. A graph is, of course, the best way to see if there is a relationship. We have a hypothesis, so what exactly should we plot? The longer the pendulum, the greater the time period? Of course, length versus time period seems the most obvious. This is what Galileo would have done originally. From your results, what can you tell about the relationship between the length and the time period? At the moment, you do not have a graph, you just have your results in the table, but you should be able to see a pattern. Does it agree with your hypothesis? Because we know what Galileo found out, we are actually going to plot a graph to help us find the value of G on Earth. So let's look back at the equation. Let's square everything, because we can. That's maths for you. So, what could we plot now? And what would we expect? Fill in this calculation in your table and plot your results on graph paper. Pause the video while you do this. So your graph should be a directionally proportional graph, a straight line through the origin. From the equation, can you explain why? Pause the video while you think about this. So let's have a look. You've got a straight line graph. Here's the equation for a straight line graph. Y equals mx plus c. So looking at our variables, y is t squared, x is L, and the intercept in this case is 0. So the gradient of our graph should be find the gradient of your graph by using a huge triangle to calculate. Remember, the triangle is the change in y divided by the change in x. Pause the video while you calculate this. Is this what you've got? I hope so. But let's be realistic. This doesn't always happen, so don't worry if your graph doesn't look exactly like this one. What you will notice is the triangle drawn on to calculate the gradient. How are you going to find G? What are your rearranging skills like? If the gradient is 4 pi squared over G, pause the video while you rearrange to find G. So G should be equal to 4 pi squared over the gradient. Of course, the gradient being the one you calculated from your graph. So what value do you have for G? Is it 9.81? I would be very surprised. Why might yours be a little different? Could you have done anything to improve your results? Something which we are familiar with in science is that sometimes the results we take give us errors, and these errors may affect our final result. Again, our students wrote up their results. Here you can see a screenshot of somebody who did theirs at home. And if we zoom in, they actually got a value of 10, which is not bad. So now you've done the experiment and you found your value of G. What would you happen if we took this to the moon? What would you expect? So here's some further reading on pendulums and clocks. You might find yourself with some time over the summer to have a read of this. We'd also like to say thank you for taking part in this taster lesson, and we'd love to see your results. Please feel free to send us your tables, your graphs, and any videos of what you've done and how close you got or not so close to finding G. We'd also like to congratulate you on working through the induction tasks. We've been working through the ones you've already sent us and are impressed by your motivation in doing these. It will mean that you'll be off to a great start when you join us in September. So take care, everyone. I hope you enjoyed the lesson, and the physics team really look forward to seeing you in physics lessons at Herts and Essex in September.